Hi students, now in this video we will discuss about the unique nature of carbon. Carbon, we know atomic number is 6 and its electronic configuration is 2 and 4, which means that carbon has 2 electrons in the first shell and 4 electrons in the second shell. So 2 electrons here in the first shell and 4 electrons in the valence shell. We have discussed in the last video that carbon has a valency of 4 and it forms the 4 covalent bonds around it to complete its octet. Now carbon has one more unique feature, that different carbon atoms can actually link together and form the long chain molecules. These long chain molecules of the carbon are very much stable, and there can be a carbon-carbon single bond, or you can have a carbon-carbon double bond, or even we can have a carbon-carbon triple bond as well. So carbon atoms can be linked together either by a single bond only, by a double bond, or through a triple bond. This unique ability of the carbon atoms to link together and form the large molecules is called as a catenation, right? The unique property of the carbon atoms to get linked together and form the long chain stable molecules, that's called as catenation. So what is the catenation? The property of self-linking of the atoms of an element through covalent bonds to form the straight chain, branched, or the cyclic chain molecules of different sizes is called as catenation. No other element exhibits the property of the catenation to the extent that is seen in the carbon compounds. The property of the catenation is shown by other elements also, like we can have silicon also, different silicon atoms also link together and form long chain molecules. But the carbon exhibits this property of self-linking, right? This property of catenation to the maximum extent, because the carbon-carbon bond is quite stable, very strong, and therefore the molecules are very stable. Other elements, they can show some catenation also, but they lack the stability, right? and if we have a CH3, then this carbon can bond with another carbon atom. This can form a bond with another one. So the self-linking property of these carbon atoms to form the long chain molecules, these are very much stable molecules, right? And this molecule here contains how many carbon atoms? 1, 2, 3, 4, 5, 6. Okay, so this is a C6 molecule, right? This is a C6 molecule where 6 carbon atoms are linked together. We have other molecules also where, you know, we can have more than 6. You know, you can have 12, 10, 20, 30, more than that, right? Even more than 40, more than 100. You know, even there are molecules which contain more than 100 carbon atoms linked together, and they form the long chain, you know, really long chain stable molecules. No other element is having such a catenation property, right? No other element can show such a long chain stable molecules, right? Okay, so carbon atoms can also link together and they can form the cyclic structures, right? Suppose you can have 4 carbon atoms in the cyclic structure, okay, and the rest of the valencies of the carbon we can fill by adding hydrogen atoms, right? Okay, so hydrogen atoms are over here. You can have 3 carbon atoms also in a chain. You can have 5 carbon atoms in a chain. You can have 6 carbon atoms in a chain also. You can have more than 6 also. So you can have open chain structures, you can have cyclic structures. It is due to the catenation, right? It is due to the catenation property of the carbon that we have open chain and cyclic structures. In a cyclic structure, you can have only single bonds. You can have also a double bond there, right? Suppose you have a double bond over here, okay, or you have a double bond over here, right? Or you can have more than, you know, 1 double bonds also, right? So there can be 2 double bonds also in a cyclic structure. So you have variety of the, you know, these compounds due to the catenation. Now let's have a look at the 3-dimensional view. Okay, let's have a 3-dimensional view of some of the compounds of the carbon, right? Okay, so this is a one such molecule. This is a cyclohexane. This is a cyclic molecule, and let's have a look at this 3-dimensional view, right? 3D view. See, these are the 1, 2, 3, 4, 5, 6 carbon atoms, right? Okay, and each carbon atom has got 2 hydrogen atoms here. Okay, you can see. Now I'm going to rotate it. Look at the 3-dimensional view. So these green atoms are what? These are the carbon atoms linked together by a single bond right here, and these white atoms are hydrogen atoms, right? Okay, these are the hydrogen atoms attached to it. So you can just see the 3D view of the cyclohexane, and this is a very much stable molecule, right? Very much stable molecule. This is a 3D view. Okay, so this is another view of this molecule. Okay, different angles, different ways to represent the molecule. So again, you have 6 carbon atoms, 1, 2, 3, 4, 5, 6, right? 6 carbon atoms, and each carbon atom has 2 hydrogen atoms there, right? Now let's have one more molecule. Let's have a 3D view of another molecule. This is really a big molecule, right? You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 carbon atoms. So this is a C12 molecule, really a big molecule, right? Isn't it? So we just have a look at the 3-dimensional view of this C12 molecule. Okay, let's see, I'm rotating the molecule here, over here. You can see this is the rotation, this is the 3D view of the molecule. And now see, these are the carbon atoms here. Okay, these are the carbon atoms bonded together through the carbon atoms. Just have a 3D view of this. Have a look at this 3D view. Okay, this is how we represent the molecule. Different ways, different expressions. Okay, you can just see 1 2 3 4 5 6 7 8 9 10 11 12. So 12 carbon atoms, right? These small structures, white structures, are hydrogen atoms, right? Really a big molecule. Look at this. Okay, this is another molecule, right? Let's have this one. See, these are the two cyclic rings together, right? This is a one cyclohexane ring, this another cyclohexane ring, and these two rings are actually linked together. Okay, so just have a 3D view of this molecule. Have a look at the 3D view of this molecule also. Okay, you can see here the different carbon atoms, right? Every ring, each ring has 6 carbon atoms. You can see here this ring has got 6 carbon atoms, 1 2 3 4 5 6. You can have the 6 carbon atoms more here. Okay, so these are linked together, 2 rings are linked together, and this is a stable molecule, right? And this is, that's how the carbon is unique, right? That's why the heading you see here, the heading, the unique nature of carbon. No other element in the periodic table can have such a variety, can have such a great number of molecules, right? Okay, so we have millions and the billions of the carbon molecules, right? It's just because of this catenation property, right? Just have a look at this, the 3D view. Okay, fine. Okay, so hope you got the concept. Thanks for watching the video. Bye for now.